Hi there once again and welcome to another Expresso mechanic tutorial. And in this one we're going to be building what you see on the screen, which is a random walker, and this is going to be another Python tutorial. We're actually going to be making this as a Python effector. At first glance it does look quite simple to achieve this, and in many ways it actually is, but it is a little bit deceptive because we won't be achieving this in quite the way that you'd expect, and we'll take a look at that when we start. But anyway, that's what we're going to be about in this tutorial, so without further ado, let's see if we can make this happen. We'll start by bringing in a sphere, and we'll make its radius just 5 centimeters, so we're going quite small here. The next thing we need to do is drop the sphere into a cloner, so we'll do that. Bring a cloner in, holding down the Option key, and we've got the sphere in it. The mode we will leave set to grid. Now the count I'm going to make 5 by 5 by 5. And the size here, I'm going to change all of these dimensions to 50 so that we tighten things up. That's it, that's fine. At the moment we're set to cubic, and this is highly versatile. We can set it to a sphere, we can set it to a cylinder, even an object. We can use anything here and it will still work, so it's very, very versatile. I think we'll leave it as a cylinder. That's given us enough spheres, I think, there. So we've got it that far, and now we can think about where we're going next. Now obviously the first thing that we need to do is bring in a Python effector, set it to full control, and then we can switch to a scripting layout, open in editor, and then we can start doing a bit of work. We'll just clear the console, and then we can remove this for loop and hit execute, and everything is set where we need it to be. I'm just going to make the window a little bit smaller here. We don't need it quite that wide. Okay, I think we're ready to go. Now the first thing we need to do, we've got import C4D up here. We can put comma random because we do need the random module. So we've got that done. We can then add our first variable, which will be the frame variable that we use so often. So frame is equal to doc.get time open close .get frame open doc.get fps open double close. And as I always say, for those who don't know, this simply gets these frame values from the timeline. Okay, we can then define our global variables, and we do need several. So global, and we need x, comma y, comma z, and finally updated, and you'll see what that is a little bit later. Now let's think about this. In order to make these spheres walk randomly, what you would think you would do is generate a random number. It will obviously be one of 6 directions because we're working in 3 dimensions. And then you would simply generate a new position vector and give it to this matrix array, or the various spheres that are within the matrix array. And essentially that's true. That's what you do need to do. However, if you work purely with this matrix array and don't do anything else, you'll find that you get a result like this. If we just switch to this file, you can already see that this is looking a bit weird. And if I run this, that's what you get. So you get an interesting result if you try and work with the matrix array directly, but unfortunately you don't get the result that you need. So we've got to deal with this. And how are we going to deal with it? Well, the first thing we're going to do is say if frame is equal to 0. And then we're going to put something in here. We're simply going to say that updated is equal to mar. So what we're going to do is actually make a copy of this matrix array, and then we're going to work with that and then give what we've set up in this updated array to the matrix array. That's how you have to do it. That's the protocol. I don't understand why that's the protocol. It must be something to do with the way MoGraph is engineered. I'm really not sure, but if anyone does know, as always, please share your knowledge. I'm interested in this stuff. I'd like to know why that works the way it does. But anyway, let's continue from here. So we've created our updated array, which is an exact copy of our initial matrix array. And we can think about what we're going to do from here. Well, all we need to do is define one function. So def, and it will be called walk, open, close. And then we can think about where we're going from here. Well, we'll start with a for loop. So we can say for I in range, and it will be count, because we want to use all of the spheres. And then we can work from here. Now, the first thing we're going to do is actually say mar square brackets I is equal to, and it will be updated square brackets I. So we're going to be getting whatever is in updated, and we're giving it to the matrix array, which is what I said that we would do. But we actually do this from the off. So initially we're effectively swapping it back to what it would have originally been. It's a bit of a strange way of working, but it's the way that it works. We can then say x is equal to, and it will be updated square brackets I dot off, not dot if, or dot off, dot x. And then we can copy this, paste it in, and simply change the x for a y. Paste it in again, change the x for a z. And we've got our real values. So we've gone from our matrix to a vector to a real value. And we've set that up, ready to go. Moving on from here, we need to decide how often we want these spheres to actually walk. So we'll say if frame is equal to, or rather frame, I beg your pardon, modulo, and we'll say 15 initially. We will be changing this a little bit later. We'll do some work to make this more interesting. But we'll say if frame is equal to 15, so every half a second, every 15 frames, we want these to walk. And we can then say is equal to 0. So that will give us that. We can then generate our random number. So R&D is equal to random, and it will be dot rand int, because we want integers, and it will be brackets 0, 5. And that will generate a random number that will allow us to walk plus x plus y minus y plus z minus z. So let's work from here. So if random, or if R&D is equal to, and it will be 0 first, of course, we can then say x plus equals, and we'll go initially 10. And again, we'll do some work a little bit later to make this more interesting. We can then copy this, paste it in, is equal to 1, and minus equals 10. So that's our x value sorted out. If we copy both of these, we can paste them here, and then change the x's for y's, and change the values. So we want 2 and 3. And then we can just simply paste again, change the x's for z's, change the values to 4 and 5. So that generates our random values to allow our walkers to move in any one of 6 directions. So that's that sorted out. We can then say updated, and it will be brackets I is equal to, or rather dot off I should say, dot off is equal to, and it will be C4D dot vector and then brackets x comma y comma z, and that's it. That is all you need to do to get these things to move. Let's see if it works. Let's have a go. Well, it won't at the moment because we haven't called it. So the next thing we've got to do is simply say walk, and let's see if it works. And straight away we can see that it is. They're all starting to walk. Now we're not finished yet because of course we need a few more frames for a start, so we'll give ourselves 1,000. But we also need a tracer, so we'll bring one of those in, drop that in there. And we've got Python in the field at the moment, which we don't want. We actually want the cloner, so we'll drop that in. The tracer, let's give it a color so that we see it more clearly. Let's make it, say, a red. That'll be fine. And our sphere will, in our cloner, in the transform here, we'll just make that a yellow. That's fine. Okay, so let's just run this now. And we can see that we're getting the trails left behind as the spheres are starting to walk. So that's all working really nicely. But it would be good if we had a bit more control over the art direction. So what we'll do is add some user data. We need to select the Python effector because that's where we must add our user data. And then we can say add user data. The first thing I'm going to do is add a group, call it controls, and drag it. Where are we? Actually, I think they've changed this now because it used to say user data there. I think they've actually updated this so that you don't have to worry about that. I think this is purely data. Yes, it is. Okay, so they've made a bit of a change there. This is Cinema 4D 2024. I'm glad they've done that. That makes life a bit easier. Fabulous. So we've got controls and we've got our first data. We'll call this speed and we'll make it an integer because we're going to be working with frames. So we can make it an integer slider, and steps of 1 is fine, and we'll go from 1 because obviously we need to have at least one frame. If we say nothing, they're just going to stand still, so we don't want that. We'll limit it. What should we limit it to? I'll tell you what, let's limit it to 2 seconds, so 60 frames. And our default value will make 10, and minimum and max will clamp those values. So we've got our speed control. The next thing we can add is some more data, and we'll say on this occasion a separator, and we want it to be a separator line, and we'll take away its title because we don't want anything in there. We can then add another group, and we can call this group walk distances. So we've got our walk distances in there. And we can then add some more data to our group, which we've done. Let's put it straight in there. And this will be x plus. Once again, it will be an integer and an integer slider. Values of, or steps of 1 is absolutely fine. And we'll say 50 for our max. And again, we'll just start at 10. For our default value, and we'll clamp the values. So that's set that up. And now what we need to do is command drag to copy it, make it x minus, copy once again, and this will be y plus, copy again for y minus, and it's a rinse and repeat for the z's. So copy that one, Z plus, command drag to copy again, and Z minus. Okay, and that is our user data all set up. So we can hit OK, and we can see that we've got it in, and it's all looking really nice. Now, the next thing we need to do is drag these in to our code. We can start with our speed, so we will bring this in here. It always puts it in the wrong place, but never mind. So we can say Python we don't need there, we can just say op. And that gives us our speed control in. So if frame modulo our speed control is now equal to 0, so it will be 10 initially on whatever we change it to. So that gives us control of the speed. And then we can think about what we're going to be doing with our distances. So for a start, we won't want this anymore. We can just drag this in, and I bet it drops it in the wrong place, and yes, it does. Drop that in there. That's our x plus dealt with. Bring in our x minus. And it's just a rinse and repeat for all of these. Perfectly simple. I'll do it by the power of editing and come back to you. Just drop the Z in there. And we're done. So we've got all of our controls from our user data within our code. And now we should be able to set things slightly differently. So we've got our speed control. I mean, for a start, if we bring this down to something like 2, if we run this now, you can see that they're scooting around much faster. So that's given us that control there, just for a start. Now, if we just make this, I don't know, something like 12, just for what it is, we can play around with our walk distances. So we'll just randomly set these up, just play around with them. Just do something like that, and then we can see what happens. And as this progresses, what we'll actually see is that it's biasing the direction in which the clones are moving. It's quite interesting what it actually does. And what we'll do, I think, in order to really demonstrate this, I'll do what I did in my original file. I'll bring in a circle and make this the XZ plane, make it 800. And I'm going to use this as basically a path that a camera can be aligned to. So it's going to be an align to spline job with a camera. So we'll bring a camera in and give it an align to spline tag. Make the, so where are we? We want the, have I got the wrong one? I think I've got an align to path. Don't want that. I want an align to spline. Give me an align to spline. That's the one I want. And then I can drop the circle in there and we can look through our camera. Now at the moment we're not looking in the right direction because we need to target. So we need a target null for a start. Just call that target. And we will give our camera a target tag and we'll target the target. And now we're looking at our clones. What we'll do is, with our align to spline, record the position at frame 0 and then skip through to the end, make this 100% and record again. So that's now set up and working correctly. And then we just need to do some more work. What we'll do, we'll record, where are we? Our camera's coordinates. In fact, our circle, I beg your pardon, we need to work with our circle. So our circle's coordinates, we can record the position Y. That's what we're really interested in. So it's just this. So we'll record that at 0, skip through to 250 frames. And let's see if we can move to see, we'll move it up so that we're looking down. I think we'll move it to, say, 300. Record there. Move through to 750 frames, move to minus 300, record there, and then at 1000 frames we'll bring things back to 0 and record there. Okay, let's see what happens. We just click off there. Yeah, and we're starting to get our movement in. And we're starting to orbit around our movers. And we can see that, you know, we are getting a change in the way that they're reacting, hopefully. And I mean, you can see it. They're actually biased in the -X, aren't they? They're actually moving more towards the -X direction, because that bias that we've introduced by playing around with the walk distances has actually changed that for us. So you can see that creating this user data, taking control of the speed and the walk distances, it does give you a lot more control over the artistic look of the thing. And that's the important thing. So yeah, I mean, it's quite a good way of doing it. I mean, another thing you could possibly do is generate random walk distances at every frame by just using more random numbers. I mean, maybe that's something you can try for yourself. But yeah, I mean, that's essentially the project complete, and we can see that it works really nicely, and it's doing exactly what we want it to do for us. But yeah, I mean, you know, this is quite a fun thing, really. I mean, it's almost like watching the sort of neurons in a brain scooting around, isn't it? It's quite fascinating, really, to watch, and very, very simple to achieve. I mean, there's really not much going on within the Python, is there? It's just as long as you know this protocol, that you must create an updated version of the matrix array in order to get this to work. You cannot work directly with the matrix array. That's the key thing in order to make this actually work. But yeah, it's fascinating stuff. Good fun. But anyway, that just about brings us to the end of this tutorial. So, as always, I really hope you've enjoyed this one and that it's inspired you and given you a few ideas for things that you might be able to incorporate in your own projects. And if you have enjoyed the video, then please give it a like. And if you haven't already, please subscribe to the channel, leave a comment, and of course, ring the bell. And wherever you happen to be on social media, please do share this video, because all this good stuff really does help keep the channel moving in the right direction. But anyway, that just about brings the curtain down on this one, so I'll see you very soon on the next tutorial.